Hey guys, this is Vaishak Pillai and welcome to Embedded In. Today we are going to talk about MQTT. MQTT is an ultra lightweight protocol built on top of TCP/IP and is the de facto protocol used for communication between the cloud and embedded systems. The central player in MQTT is the broker. It is nothing but a server to which many clients can connect to. There are two types of clients, publishers and subscribers. When a subscriber connects to the broker, it indicates a topic which it is interested in. When a publisher connects to the broker, it indicates a topic to which it is publishing a message. Consider that there are two subscribers connected to the broker, S1 and S2, and both of them have subscribed to the topic T1. Now let's consider that a publisher connects and sends a message M1 to the topic T1. When the broker sees a message on the topic T1, which S1 and S2 have subscribed to, she'll forward the message to both the subscribers and they'll both receive it. This is the central idea of MQTT. MQTT has a lot of nuances which you can go into detail, but we're going to stop here and we're going to jump into a hands-on session to see MQTT protocol in action.
The broker that we are going to play around with is Mosquitto Test Open Server. So if you go to test.mosquitto.org, you will see that there is an open server available for you to test different kinds of MQTT connection. To start with, to understand the concept, we will try to connect over the unencrypted 1883 MQTT port. For this, I am using two WSL consoles. Once you log into WSL, navigate to your working folder. First, we need to install Mosquitto clients. So you type in sudo apt get install Mosquitto clients. Once you type in the password, the clients will be installed and this will give you two commands, Mosquitto pub and Mosquitto sub. This indicates a publisher and a subscriber. So at first, let us subscribe to a topic and then publish a message to the same topic from the other window. So to subscribe, what you do is mosquitto_sub. You need to provide the host. In this case, it is test.mosquitto.org. The port is 1883, the unencrypted port that we are using. And let us say that we are going to subscribe to a topic test/Vaishak. I'll also add a debug flag so that we can see the steps that are going on here. So as you can see, we have connected, we got a connect acknowledgement, and then we subscribed to the topic test/Vaishak. And we got an acknowledgement for the subscription. Now I go to the next terminal and I'll use the publish client mosquitto_pub, same host, test.mosquitto.org, same port, 1883, the same topic as well, test/Vaishak. And now we need to provide a message. Let us say hello. And here also I am enabling the debug flag. I need to give a space here. As you can see, the published client connected, got a connection acknowledgement. He published a message, which is 5 bytes here, to this topic, test Vaishak. And on the left hand side, since we had already subscribed to this topic, we received the message. Now the problem is that we are connecting over an unencrypted network, 1883. If you go back to the Mosquitto server, you can see that there are multiple ports on which this server is listening. This 1883 is the unencrypted one and 883 is the encrypted network through which you can access the same server. This is very much similar to a web server where on port 80 you will have unencrypted access, non-TLS access, and on port 443 you will have encrypted TLS based communication happening. Both these ports point to the same server and this is very much similar. Now when you want to connect to a server over a secure port over TLS, you need to first verify that you are connecting to the same server that you intend to. That is one of the central ideas of TLS. We are not going into a lot of details about TLS here now. Eventually we will cover that. Now to connect to the server, we are going to download the certificate that is given in the Mosquito server itself. Click on the org cert. It will give you a pop-up asking you to save the file. I'm going to save it to the same working folder. And I'll go back to the clients and cancel the subscription. Now we're going to connect over the secure port 883, same topic. Just that now we need to say which certificate we need to use for the connection. So we use the CS cert argument and provide the Mosquito certificate. Sorry, the argument is CA file. Right. So we are connected, similar connection as before, but the main difference is that now we are connected over an encrypted network. To show that we are connected to the same server over both the interfaces, the secure and the non-secure interface, I'll still publish using a non-secure port as before, the 1883. I click enter and I'm publishing a message over the unencrypted network and I receive it in the encrypted network here. So when you think about an embedded system, say assume we have a light bulb, consider that each light bulb has a unique identity which is thing ID. Let us call it as T1. The specific instance of the bulb is T1. And if we have 100 bulbs connecting to the system, each of them will have a unique thing ID. And the broker in our system is going to be AWS IoT. At its heart, it is nothing but an MQTT broker to which devices can connect. So on this thing, we're going to run an MQTT client, which is going to subscribe to the T1 topic, which is nothing but the thing ID here. It will be connected. Any message coming to the broker on the thing ID topic will be forwarded to the bulb. Now, our web application is going to be a publisher. In this case, it was subscription. The web application, when it wants to control the light bulb, is going to publish a message on the T1 topic. The message will be on or off. As soon as the thing receives the message, it will take a corresponding action and light up when the on command comes in. As you would have imagined, this is pretty unsecure because anybody will be able to publish on the T1 topic and control my bulb. So that is where the system design aspect and security comes into picture. And this is what we will deal with in the subsequent sessions.